Last Wednesday, Thursday, Friday, we were looking at using square roots, so it was a perfect square. We took the square root of both sides to get x by itself. So today we're going to do something called completing the square, which is a method to get the equation to look a certain way, look like a perfect square, so that we can then take the square root. And then the last method, method number 4 that we'll be learning this week, is called the quadratic formula. So there are 4 different ways that we can solve something that has an x squared. That means when you're given an equation, you have really 4 different options to choose from to kind of approach solving the problem. So we'll be talking about all 4 of those methods and reviewing them on Friday. Right now it looks like I'm hoping to get in your chapter 4 test on Tuesday before you leave for your Thanksgiving break. So that would be including a little bit of the graphing, all of the factoring, and then like the different ways of solving an equation, quadratic equation. So I'm really hoping that next Tuesday we can get that chapter 4 test in. Otherwise it'll be the Wednesday, like you come back, the Tuesday you come back, which pretty sure you don't want to take a test on Tuesday you come back. So I'm really going to try and get it in. We'll see how it goes this week, and then I'll let you know on Friday for sure. But on the worksheet, the review worksheet from Friday, what question would you like to go over? Questions would you like to go over, talk about? Abby? 17. So number 17 is at the top. And we have x squared plus, or equals 2x squared plus 4. So our goal is to solve for x squared. Any equation that you're solving for x, one of the things you want to try and do is think about how can you get the x squared by itself, how can you isolate it. So in this question, what we do to get x squared by itself? Yeah, so we have x squares on both sides. Let's combine them together. So she said subtract 2x squared. So Maddie, we have 1x squared minus 2x squared. That gives us?
Negative x squared.
Negative x squared. And then Maddie, what else would you do?
I divide by negative 1.
Yeah, so divide by negative 1 because we want the x squared to be by itself. So then we have negative 4. And then finally? Alright, so the x squared is by itself now. We need to take the square root of both sides. The square and the root cancel. And then when there's a negative underneath the square root, that makes what, Maddie? Yeah, that makes our imaginary number. So this negative comes out, makes the imaginary number I. Anytime there's a negative underneath the square root, that's how we get that imaginary number. And then Maddie, the square root of 4 is?
Plus or minus 2.
Awesome, nice job. So the square root of 4 is plus or minus 2 because 2 times 2 makes 4, but negative 2 times negative 2 also makes 4. And then the negative part underneath the square root is how you get the I. So plus or minus 2 and then I. Don't forget the plus or minus anytime you're applying a square root because we're solving for x squared. There now needs to be 2 answers because it's a parabola. Parabola has a left and a right side. It's not just a line. So that's why we have that plus or minus. One to represent the left side of the axis of symmetry, the plus to represent the right side of the axis of symmetry. Is there another question from the worksheet you'd like to go over? Say it again. 19? All right, Maggie, what did you do first? Yep, so if we add 5x squared, we end up getting 16x squared. And then what, Maggie? Yep, that's perfect. Divide by 16. So we have x squared equals negative 1/16. So just like we did over here for number 17, x squared equals negative 4. So we have x squared equals negative 1/16. We'll take this square root. And we end up with x equals, pulling the negative out, that gives us the I. And then the square root of 1/16, think of that as the separate pieces of the fraction, the square root of 1 and the square root of 16. So Maggie, the square root of 1 is 1. And the square root of 16 is 4. We took a square root, so we have that plus or minus that goes in the front. So the square root of the top number, the square root of the bottom number. When it's a fraction, you can really think of them separately, taking the square root of each of them individually. But the square root of 1 is 1, so we don't want to leave it as the square root of 1 because it becomes the number 1. And then that I, you can put that I anywhere. If you want to have it on the top, you can put it on the side. I kind of just separate the 1/4 from the I. You can place that wherever you'd like. Any other questions? Melanie?
Can you do 15?
Yeah. So 15 is a problem that has parentheses in it. So we have 2x plus 2 squared minus 5 equals 8. So Melanie, how'd you start this problem? Yeah, so just like it was an equation, just with an x, we always try and combine like terms, take things away from the x to the other side. So we add 5. And that gives us 13. And then Melanie, what else would we do? Divide by 2. So in this case, we're still trying to get x by itself, but it's that parentheses that we're trying to get by itself. So we now have x plus 2 squared equals 13 halves. Let's see. So the x squared was by itself in the previous two problems. The parentheses is by itself and it's squared. That means we have to get rid of that quantity that's squared. We need to get rid of that squared term, so we have to take the square root of both sides. So the square and the radical cancel. That's the whole goal. It's like undoing itself. They're opposites of each other, like multiplication and division. We're left with just x plus 2. But on the other side, we have the square root of 13 and the square root of 2. Bless you. And I'm going to throw a plus or minus in front here so we don't forget that as well. So just like I did with the previous fraction, the square root of the top and the square root of the bottom. What do you have to do with this fraction? Maddie? Right, and that's called rationalizing the denominator. Nice job, Maddie. So the square root of 2 cannot stay in the denominator. We have to have a whole number down there. So to get rid of the square root of 2, we need to multiply the top and the bottom of the fraction by the square root of 2. So that gives us a whole number in the denominator of 2 and not a square root in the denominator. So multiplying the top, Maddie, the square root of 2 times the square root of 13, these guys make square root of 26. And the bottom, the square root of 2 times the square root of 2 is? Right, so this is the square root of 4, but that becomes 2. And that's the goal of rationalizing the denominator. So that you have a whole number in the denominator by multiplying it by the square root of whatever's sitting down there. And then the last thing, I left a little space here because we need to take that 2 to the other side. So we'll subtract this to take it to the other side. It goes in front, we have the negative 2, because that's the real I'm sorry, the integer part, and then the plus or minus with the radical, the square root of 26 over 2. So that had a quantity in parentheses. That's why we now have these two pieces to the problem instead of just the one answer with an I. You've got that number, the plus or minus, and then that second piece. You cannot actually combine them together because they're not really the same type of number. So this is an integer, this is a radical, they kind of just stay separate from each other. We don't actually pull them together and reduce them further. Questions? Good questions to ask. So if you can make sure your name is on that worksheet and pass that forward. section 4-7. I give you a paper cut.
No.
No. Kind of crazy that it was snowing Sunday, but Saturday morning there was snow. They said maybe tomorrow morning a little snow, and Erie had 10 inches. A little too cold yet, right now. Too cold. Shouldn't be winter yet. So we're going to talk about a process called completing the square. And if you look at the top, there's a couple little warm-up questions. And the first two just kind of review exactly like the problems we went over. So we have x minus 5 squared equals 49, x plus 6 squared equals 20. Part 2 is a little review of factoring. So we'll kind of look just to review these. And you will have probably 2 factoring quizzes this week, little factoring quizzes to kind of just review that process. But in letter A, if we take the square root of both sides, because that's how you get rid of something squared. Julie, Jillian, what do you have when you take the square root of both sides?
You would have x minus 5 equals 7.
And what goes with that 7?
Plus or minus.
A plus or minus, right? And that's the tricky thing to remember. Anytime now that you're solving for x squared and you apply a square root in the problem, we have that plus or minus because we're solving for the term x squared. So Jillian, how do you solve this then? X minus 5 equals plus or minus 7.
Just add 5 to the
So add 5 to both sides. So if we add 5, we have plus or minus 7 and then plus 5. So this really says that we have a positive 7 plus 5 and a negative 7 plus 5. So Julian, the 2 answers would be
x equals 12 or x equals
right. So because they're actual numbers, we don't have square roots, you can combine them together and get 2 values for x. So we have a value for x of a 12 and a value for x to be negative 2. And you do want to combine them together because they're both the same type of number. They're both integers. You combine integers together. So we have nice numbers there of 12 and negative 2 for x. So looking at B, if we do that same step, take the square root. But here we have the square root of 20. And can we take the square root of 20 and get a nice answer, Emma? No, but instead, what can we do with the square root of 20? We can take a 4 out, and it would become 2 times the square root of 5. So the square root of 20 isn't a perfect square, but we can still break it down by taking this perfect square of 4 out, and then make that 2 times the square root of 5. That also gets a plus or minus in front of it. Because again, we put the square root, we're solving for x squared. Emma, what does this answer look like then for x? Can you combine those together? No. So in the first problem we could because they were both numbers, integers, the same type of numbers. Over here you have an integer and a radical. They are not the same type of number, so this answer would not be split up and combined together. Instead, we would just keep it together as negative 6 plus or minus 2 square root of 5. So when you get an answer that looks like letter B, that means the problem can't be factored. So if we try to use the factoring method, this one could not be broken down or factored. If we get an answer like letter A, that means factoring is one of the ways that we could approach the problem. When you factor, you get nice answers because you have 2x plus 5, x plus 3, 5x minus 2. But when you're factoring, you factor with nice values. Any other method of solving, and you end up having like radicals, that means a problem could not be factored. So when we were factoring and we said the solution cannot be factored, this is what happens when we can't factor it. We have to kind of approach it another way. So looking at the second group of problems, these want you to factor the expression. We have x squared plus 18x plus 81, or x squared minus 22x plus 121. how do you factor x squared plus 18x plus 81? Julia?
If you notice that the first and the last numbers are perfect square, you can square root.
Yeah, so she said if you notice, the first and the last numbers are perfect squares. So this is a special pattern, and that special pattern says a squared plus 2ab plus b squared equals 1 parenthesis squared. Because you can take the square root of both of those numbers, and Julia, the square root of both of those numbers would be?
X plus 9.
Right, x plus 9 squared. So that matches a special pattern. The first and the last number are perfect squares. And then for letter B, Julia, it's that same pattern with a minus sign, so this would be
X minus 11 squared.
x minus 11 squared. Again, 121 is a perfect square. X squared is a perfect square because x times x makes x squared. So today, we're going to be kind of combining these two steps together. We're going to try and get problems to look like letter A and B in the second step. And then we're going to solve them using this process that we used up here. So it might not initially look like a nice perfect square, but we're going to try and get it to look like that. That will be our goal today. The last little question here, just kind of thinking about this, 27 plus some number equals 6 squared. What is that number? So 27 plus some number is equal to 6 squared. What would the number be? That's x. 9. 27 plus 9 is 36. 36 is equal to 6 squared. So if you look at the first problem here, it wants you to solve by finding square roots. So we're going to try and combine the first two warm-up problems together. If you look at the left side of the equation, we have x squared minus 8x plus 16. It's equal to 25. When you have a trinomial on the one side, usually we try and do something with that trinomial. Factoring is usually the easiest thing to do anything with a trinomial, which means you have that a, b, c. So if I cover up the 25, ignore the 25, what can you do with the left side of the equation? So x squared minus 8x plus 16. What can we do with that? Melanie?
We factor
Yeah, and how would that factor?
x minus 4 squared.
Yeah. So it factors as x minus 4 squared because they're perfect squares. So if we can factor it, it makes it really easy to then completing it and finishing the problem and solving it. So Melanie, how would you solve this problem now that we have this x minus 4 quantity squared?
Square root.
Yeah, square root both sides. So it's kind of taking a and b and combining them together in a problem. So it doesn't look like it can be square rooted, but we can kind of change the way it's written. Melanie, the square root of 25 is 5, and we plug that plus or minus in front of it. So really we have x minus 4 is equal to positive 5, and x minus 4 is equal to negative 5. That's what that plus or minus means. So one answer is a positive 9, because when we add 4 to 5, we get 9. A second answer is a negative 1, because when you add 4 to negative 5, you get a negative. Questions? So I think at the bottom of your page, you have the term completing the square, and then underneath there's a couple of little like algebraic things to think about. So completing the square is a process or a method. We'll say method. Used to solve a quadratic equation. I missed the word solve. By making a perfect square trinomial. So So that means that the first number and the last number are perfect squares, like the last problem we just looked at, that x squared minus 8x plus 16. So it's a method that we can use to solve quadratic equations by making a perfect square trinomial. Completing the square is a process, a method like factoring. You use the same steps every time to approach the problem. So to complete the square, for the expression x squared plus bx, we're going to add a quantity and that quantity is going to be bx over 2, and then it's going to be squared. I'm going to take away the x up here. We're just going to make it a b. So what this is saying is to get a third value, so we have x squared plus bx, and then we want this number back here to be a perfect square. So to get that number to be a perfect square so that it goes along with the middle term, we're going to take that middle term, divide it by 2, and then square that number. So that it looks like x squared plus bx plus b divided by 2 squared. Because if I square something, then it's a perfect square. That's what a perfect square means. A number squared is a perfect square. So it would look like x plus b over 2 times x plus b over 2. Or, since they're the same quantity, x plus b over 2 squared. But that's how I can get this middle number. So there is 4 steps, but they're short steps that we can use to help us complete the square. And that is on the top of the next page. So our goal is to make a perfect square trinomial. That means that last number is a perfect square. So it says find the value of c that makes the expression a perfect square trinomial. Then write the expression as the square of a binomial. I know that seems confusing, it's a little wordy, but we'll look at a couple examples and you'll see that it really isn't too bad. It's just the terms up here make it a little wordy. So the first part, it says find half of the coefficient of x. So if we have x squared plus bx plus c, we're going to take half of the coefficient in front of x, or half of b. So if I'm taking half of something, I'm dividing it by 2. The second step, square the result in 1, or we're taking b divided by 2 and squaring it. So we're taking it, cutting it in half, but to make it a perfect square, we have to square that number. The third step, we want to replace c with this answer that we get here. So we're going to take this number, take it out of the problem, we're going to replace it with the answer that we have. And then finally, we're going to factor it into a perfect square trinomial. So our goal is to make a problem that is factorable. That's our end result. Can we come up with an equation or an expression that we can factor by using a perfect square? So there are 2 examples underneath. 2 examples underneath. Here we go. And a c term is missing. So this piece right here is what we're going to try and make a perfect square using the process above. So we're trying to find a number that makes this equation or this expression a perfect square. So the first part says to take half of the coefficient of x. Well, the coefficient is the number in front of x, just the x term, so that's the middle. So we're going to take 12 and cut it in half. So you're taking the middle number, you're cutting it in half. Step 2 says square this result. So I'm going to take this and square that number. So Holly, 12 cut in half is 6, and 6 squared becomes 36. Step 3 says replace c with the result that you just found. So we now have x squared plus 12x plus 36. And now factor this. So how does it factor? Jillian?
X plus 6 squared.
Great, now it factors as x plus 6 squared. So we found a number to make this problem factorable into a perfect square. Because 36 is 6 times 6, so x plus 6 squared. So the second one, we have x squared minus 24x plus c. So we want to find a number that makes this equation or this expression into a perfect square. So if I follow the steps, take the middle number, cut it in half. It's negative 24. We're cutting that number in half. And then we're squaring it. So the middle number divided by 2, and then we square that value. So Eden, negative 24 divided by 2 is, and negative 12 squared becomes 144. So we rewrite it, x squared minus 24x plus 144. And then Mackenzie Myers, how would this factor?
X minus 12 squared.
X minus 12 squared. Questions? So completing the square, we found a number to make this a perfect square. That's really what completing the square means. So we want to complete this expression so this number is a perfect square. So if you look down below, go down to number 2, where it says find the value of c that makes it a perfect square, trinomial, and then write it as a square of a binomial. That just means to factor it. That's what that expression means, or that sentence means. Write the expression as a square of a binomial is another way of just saying factor it. So when you see those directions in your book tonight, it's just another way of saying factor it after you wrote it as a perfect square. So Rebecca, we have 22. We're going to divide that by 2. 22 divided by 2 is what?
11.
What is 11 squared?
121.
Excellent, 121. So we took the middle number, cut it in half. We're squaring it, so that gives us the perfect square of 121. So now we've completed the square. We found the number that makes this a factorable problem. And then Rebecca, how does this factor?
X plus 11 squared.
Yeah, x plus 11 squared. So letter B, we have x squared minus 9x plus c. So Gabby, if we have negative 9 divided by 2, this one's a little messier. Do you know how to square a fraction without making it a decimal? How do you square a fraction without making it a decimal? Without using your calculator even. Put it?
Could you start by multiplying that by 2?
Even easier. Huh?
You just square the top number.
Yeah, square the top number and the bottom number. Yeah, so you don't need to multiply it by anything. If you just square the top number and square the bottom number, then you've squared a fraction. So, Connor, negative 9 squared is 81. 2 squared is 4. I know it looks weird because it's a fraction, but definitely doable without a calculator. If you're squaring the top number, you're squaring the bottom number. So we're going to write this into our expression, x squared minus 9x, and then plus 81 over 4. So they don't all have to be nice, perfect numbers. We can have a couple of fractions in the problem. So the second step is to factor this, and this is where it's a little weird. We would have x, it's going to be a minus sign because there's a minus sign here. And then we need some number that's going to be the square root of 81 fourths. Connor, do you know what the square root of 81 fourths is? 9 over 2. So we squared it to get 81/4. Well, to get it to factor, essentially you're going backwards because the square root of 81/4 is 9/2. So you square the top and the bottom to get the quantity squared so that it's factorable, but then when you're factoring it, you're actually going backwards and you're going back to that 9/2 value. Questions? So when it's a fraction, square the top and square the bottom, or take the square root of the top and the square root of the bottom. Alright, so all of this is kind of leading up for us to be able to solve an actual equation by using this method. So if you look at the bottom of your page, I have the steps listed, or is it at the top of the next page? Bottom? Yeah. I have the steps listed next to it, and it wants us to solve an equation when the a value is 1. So we have x squared minus 10x plus 13 equals 0. The reason this process was created is because some problems are factorable, but it doesn't mean we can't solve them. Mathematicians don't like problems that don't have an answer or that cannot be solved. So they will always try and find a new method to solve problems for x. That's what kind of math, a lot of math is about, finding x. So if you can't factor it, well, math people want to find a new way to find the x value without factoring. And completing the square is one way that we can find x for problems that are not factorable. Because if I have a 13, there are no two numbers that multiply to be 13 that combine to be negative 10. That's the process of factoring. So 1 and 13 make 14. Negative 1 and negative 13 make negative 14, but they're not going to be negative 10. So how can we solve a problem that can't be factored? So over here, it's a 4-step process, but again, it's kind of like the first couple of steps are pretty much all pulled together. But the first part says eliminate c by adding it to both sides. Because currently, 13 is not a perfect square. And our goal is to make a number that is a perfect square. So if it isn't a perfect square, we kind of want to just like take it to the other side and forget about it. So we're going to keep the x squared and the negative 10x. I'm going to leave a little blank here where 13 was. And I'm going to take the 13 that's sitting there to the other side. So now we're going to do the process that we just did for 4 problems above. We're going to take b divided by 2 and square it, because that's how we can get a number that is a perfect square. And I missed an x right here. Make sure there's an x there. Forgot that. So Will, what number are we using for b? Okay, and how did you get that? So negative 10 divided by 2. Square it, and he said that makes 25. Because it's now an equation, what you add to one side, you have to keep equivalent and do the same thing to the other. So it says add this value to both sides. So we're going to add 25 where the 13 was sitting, but we're also going to add 25 on the other side. Because that's what makes it an equation and not an expression. An equation, we have to keep both sides equivalent. Whatever you do to the one side, you have to do to the other. Part C says factor the left as a perfect square. So now this left side, Will, how can we factor that as a perfect square? And it would be x minus 5. So it's now factorable. We completed the square. We can factor the left side as a perfect square. Will, do you know what negative 13 plus 25 makes? 12. The last step says proceed to solve. How do you solve this problem now? So what do you do to solve it? Using the method that we talked about last week. Yeah, take the square root of both sides. So we've completed the square. Now we're using that square root process that we used last week. So we have x minus 5, because the square and the root cancel. Maddie, how would you break down the square root of 12? So this becomes plus or minus 2 square root of 3. And then bring the 5 to get x by itself. So adding 5 plus or minus 2 square root of 3. So we completed the square, and then we solved using the method from last week. So if you flip the page, I'm going to do another example so that we can kind of do another full problem together. So the same process for every problem. And again, the reason we have this process is to solve problems that cannot be factored. So you can't factor them, so all right, what's another way to work through the problem? So we have x squared plus 6x minus 4 is equal to 0. So the first step is to take that 4 to the other side because we're going to find a new number that works with the 6. So we have x squared plus 6x. Leave a little space because in this space we're going to place a number that is a perfect square that goes along with the 6. And to get that number, you're taking b divided by 2 and squaring it. So Maggie, 6 divided by 2 squared is? And 3 squared makes? 9. So we're going to add 9, add 9. Whatever you do to one side, keep the equation balanced. You have to do the same thing to the other. All right, so we have x squared plus 6x plus 9. Abby, what's the left side factor as?
X plus 3 squared.
X plus 3 squared. And it's equal to 4 plus 9 is? 13. And then proceed to solve. So it's completed once you have that quantity squared. Now we just have to finish solving the problem. So take the square root of both sides. Abby, can you break down the square root of 13 at all? No. So it's just going to stay with a plus or minus in front of it. And then your answer, you'd subtract the 3. So negative 3 plus or minus, and then the square root of 13. Questions? So every time, the same process. You move the c to the other side into that b divided by 2 process. That's the completing the square process so that we can get it to a factor. Questions? So the homework tonight, 3 to 21 odd, are just doing pieces of the completing the square. So you're going to find the number c. You're going to solve it because it's already a perfect square. There's the last couple of problems, and I think there's 6 of them, 22 to 27, where you're actually working through the whole process of solving for x. So I'd like somebody to do 23 and someone else to do 27. And I still have a whole bunch of you that need to get your first one, Eden and Joel. So Eden 23, Joel 27. So we're going to work on this more tomorrow, but we're going to add a number in front of the x squared so that we would have like a 2x squared or a 3x squared, just to see how it changes the problem when you have that extra number in front.